My name is Jason Dunnigan. I'm a regional sales manager for A+ Corporation, and this video is going to be to demonstrate how to install and retract our Genie Direct Drive Probes. Specifically for this video, we're using the model number 755, which has the membrane on the tip and the integrated pressure regulation. Unlike the GP series probes that have a housing that need to be installed through a threadlet and a process connection, these direct drive probes do not have a housing. They don't require one. They install directly through a full port ball valve, so you can do it under line pressure and not have to worry about blowing down the line for installation. Unlike the GP series probes where the probe length you order is also the insertion depth that you'll get, direct drive probes are fully insertable up to their full length. The reason we bring that up is these probes are also used in our ACES systems, which are the heated and closed systems. In that case, they have to be fully inserted. If they're going to be installed as a standalone probe like we're doing in this video, you can install it up to its full length. An example of that would be if you had a 12-inch probe, but you only needed to insert it 6 inches. You can actually do that. You don't have to do it the entire length. The first few steps that we're going to talk about are actually more like checklist items before the physical installation of the probe begins. The first thing we're going to talk about is pretty obvious for anybody who's going to be doing the actual installation, but we want to make sure we point it out, and that's making sure you have some Teflon tape on the process threads at the bottom of the probe. There are two reasons that we bring this up. We suggest using nickel-infused Teflon tape and not just your regular Teflon tape. First reason for that is that the nickel infused tends to create a better seal on stainless steel threads. The second reason is that it helps to protect these threads from galling. Another one of the checklist items we want to mention is to make sure that the probe is fully retracted. That way the bottom of the probe tip is not down far enough to where it could possibly contact the inside of your process ball valve. The next thing is there's a regulator adjustment screw here at the top of the probe. We want to make sure that you thread that back far enough to where it starts to turn easily, but not so much that it comes out of the top of the probe. The reason for this is that once it's backed out far enough, it does not contact any more of the internals of this regulator, and so no outlet pressure is allowed to come out. So that's just an additional safety feature that was designed in the internals of this regulator so that during installation you don't have any process pressure coming through. You'll also want to make sure that the valve you have on the outlet of this regulator is closed off. In this case, we have our specifically designed manifold, accessory manifold with a ball valve, but even if you use one that you provide yourself, just make sure that this is closed as well. That will prevent any outlet pressure from coming through and escaping in case you either forget to thread this regulator adjustment screw back, or if somebody comes along between the time that you did it and you're going to install it and played with it and threaded it down so far that it actually can have some outlet pressure coming through that outlet port. So once you've finished your checklist items, you should be ready to install the probe directly onto your process ball valve. And you do that by threading the NPT threads at the bottom of the probe body into your full port ball valve. You can do this by hand, and in most cases that's tight enough onto the process connection. If you would like to snug it up, you can either use a 1 3/8 inch open end wrench or an adjustable wrench. We just want to point out, you want to make sure to use the wrench flats that are actually on the top of this probe body and not the wrench flats that are on this packing gland nut. If you use this packing gland nut, it's not going to turn as well. It's not actually going to tighten it down as well. And you'll end up crushing the packing that's inside of that probe body. Since the threads at the bottom of the probe body are MPT threads, we don't really have a torque value rating for them. You just want to make sure it's nice and tight. Make sure that it's nice and sturdy and it's got a good seal to your process connection. But you just want to make sure that you don't over tighten them, because you can gall those threads and damage the body of the probe. So once you're ready to install the probe, if you got it on your process line, you have not opened the process ball valve yet, you want to determine what insertion depth you're going to need. In this case, we'll use 4-inch insertion depth. And so what you do is you'll measure from the top of the probe body here, not the top of the packing gland nut, but the top of the probe body, up the rack. So roughly here. And we cheated a little bit in the video and got the marking nuts here, but you'll notice that the marking nuts that are on this rack, those are used to actually indicate where to stop threading the probe down into the line, so you're not guessing. So once you get that measurement from the top of the probe here, or the top of the probe body, to whatever insertion depth you want, 4 inches in this case, you'll thread this bottom marking nut down to that point. Once it gets there, you'll thread this top marking nut down until it contacts the bottom nut. And what that does for you is it sort of locks them in place. So if anybody comes along and plays with the marking nut, you can't thread it back up. You know exactly where it is. If you have to retract it for any reason and then you want to go back down, it'll already be marked for you. You don't have to do it again. At this point, you've checked off all the housekeeping type things before you install the probe. You've got it threaded into your process connection, and you've got your marking nuts marked so you know where to stop this so that you have your desired insertion depth. And so at this point, you can actually open your process valve. Once you're able to do that, you'll be able to start threading down the probe and get it inserted into the desired depth inside of your line. These direct drive probes are designed to have a pressure balance technique inside of this rack. So the sample path that your process will flow through, it actually takes that process pressure and it fills the inside of that rack, so that when you start threading the probe down into the line, you're not working against full line pressure. Once you're ready to thread the probe down inside the process line, you want to make sure that you're using these wrench flats that are at the top of the probe rack here, and make sure that you're not putting your wrench actually on the threads themselves, because it can damage it. So you can use either a open end wrench, an adjustable wrench like a crescent wrench, or what we recommend, especially for the longer length probes, is our optional speed wrench, which is available for purchase separate from the probe from your local distributor. So we'll put this onto those wrench flats that are on the top of the probe rack, and then we'll start to turn it down to the desired depth. So a practical tidbit about when you thread this down to the insertion depth that you marked with that bottom marking nut, is that your gauge doesn't always end up facing the way you want it to on the pipeline. So it's okay to, once you get to that point, to kind of turn it counterclockwise a little bit, even up to a full revolution. It's not a big deal. It's not gonna affect your overall insertion depth that much, but that way you can turn it to where it's easy to see whenever you walk up to the line and be able to see the gauge and everything. Now you want to check for leaks around the probe. The main spots to check for these leaks are at your the outlet of the regulator, at your ball valve, your outlet ball valve, down at the process connection, obviously, to make sure you have the body threaded in nice and tight, but not over tight to where you damage anything. And then probably the most important and most likely place that you might have a little bit of an initial leak when you first install a probe is here where this packing gland nut is, to seal off where the packing gland seals are inside the body at the top. And so kind of a little note that we try to make sure and point out to people when they install these is that the process conditions and the type of sealing material you have in here are going to determine how much you have to tighten that down. If it's a neoprene rubberized type seal, you typically don't have to tighten it down quite as much. We don't really have a torque rating, typically hand tight, and then just using some snoop to see if you've got it tight enough and there's no leaks is fine. But it's typically 10 to 12 foot-pounds is what it equates to if you really needed just a range of a torque value. If you're using a higher durometer seal like an RGD resistant HNBR type seal for a supercritical service or for liquefied gas service, things like that, then it's going to need a higher torque value because it's a harder, more rigid seal. In that case, we typically recommend up to about 75 foot-pounds, but most of the time about 65 foot-pounds will do on this. And again, that's what these wrench flats on this packing gland nut are. You may want to, if you have to thread this down a significant amount, relatively speaking, it may be a little bit further away from this. So just make sure that your marking nuts stay where they need to be for your insertion depth next time. One other thing we like to point out is that over time, you may need to snug this packing gland nut up some, because if you retract it to check or change the membrane, or you pull it up out of line, possibly for a pigging operation, things like that, the more it is retracted and then reinserted, it can loosen that packing gland nut a little bit. It's not a defect. If you have little leaks after something like that happens, you want to always check the seals and the packing rope that's inside of there to make sure it's not damaged. But typically, over time that can happen, so don't be alarmed about it. Just make sure that you do snoop it each time you retract it and then reinsert it and snug it up if needed. So your probe's inserted, you've got the process ball valve open to line pressure, and now what you want to do is to start threading this regulator adjustment screw down clockwise until you see outlet pressure coming out, which will be indicated by this gauge. Once you see that start, you can turn it to whatever outlet pressure you need for your analyzer. Once you get that set, much like these marking nuts on the rack, we have a little nut that's on this threaded regulator adjustment screw. So once you get your outlet pressure where you need it to be, you can thread that nut down until it contacts this washer on the top of the regulator, and that'll kind of hold the place. You won't be able to tighten it anymore, so you won't be able to easily come by and turn it clockwise anymore and get a higher pressure than you actually need. Once that's done, then you can open up your outlet ball valve, and that'll actually start to send your sample down the transport tubing to your analyzer. So this section of the video is for retracting the probe out of the process line if you need to check or change the membrane, or if you need to retract it up in case you're doing a pigging application or something like that. First thing you want to do is, obviously, again, we don't have the sample transport tubing connected, and we left the outlet ball valve closed just for this demonstration, but it'll obviously be open in a normal flowing line situation. So you want to close off this outlet valve and then disconnect your sample tubing. That way, whenever you're retracting the probe up, you're not bending any sample tubing or damaging any fittings on your sample transport tubing. So with your open end wrench or your adjustable wrench, or preferably your speed wrench, you want to, again, make sure you're using the wrench flats on the top of the rack, and start to turn it counterclockwise to retract the probe. You just want to make sure that you retract this fully. You'll be able to feel it come to a mechanical stop whenever you get it fully retracted. What that does is that basically lets you know that you've got the tip of the probe above the process ball valve, so you can close it off to the line pressure. Okay, now that the probe is fully retracted, you can close your process ball valve. And then you'll want to open up your regulator outlet valve to vent any of the residual pressure inside of there. No reason to get nervous if you hear that come out. Just open it slowly. It's not because of the line pressure, it's just a little bit of that residual line pressure gets trapped in between the regulator outlet and the tip of the probe inside the sample path in the rack. And then I typically recommend that once you vent that, to go ahead and thread this back again, so that you don't forget to do it whenever you put it back on next time you reinsert it, if you're going to take it completely off, or whenever you get ready to connect everything. Now that you've retracted the probe fully and vented any residual pressure inside of the probe from your outlet valve, now you can just unthread the actual probe body from the process connection. And that way, if you needed to do any kind of maintenance, or you just wanted to check the health of your membrane, or if you need to look at the regulator seat cartridge assembly inside, anything like that, you just thread it off. Your process ball valve is safely closed, and you've safely removed the 755 from the line. Something we like to point out before reinstalling the direct drive probes is we suggest using some kind of thread lubricant on the rack. It helps for ease of movement as you're inserting it or retracting it back out of the probe. It also just kind of helps with maintaining the integrity of the rack itself. We specifically use Krytox GPL 206. Note, remember to reapply Teflon tape to the probe's process connection threads before reinstalling.